Hey folks, this is Joe Rule with the Bold Visions podcast, where I interview people who work with disruptive technology about how they use the power of storytelling to bridge communication gaps and make vision into reality. Show notes and links for this episode can be found at raconteuranimation.com/podcast. And as always, this episode is sponsored by Raconteur Animation. Today on the show, I spoke with Alex Kingsbury. Alex is a well-known additive manufacturing technical expert and has worked in metal additive manufacturing and technical leadership and advisory roles for the last 10 years. She is currently the market development manager for nLIGHT, a leading provider of high-power semiconductor and fiber lasers. In this role, Alex leads nLIGHT's additive manufacturing business, facilitating the adoption of lasers that provide the next breakthrough in quality and productivity in additive manufacturing. And in the beginning of the episode, she does explain some of the tech behind that and how it works. Then, prior to nLIGHT, Alex held leadership positions at CSIRO and then RMIT University, both in Melbourne, Australia. Additionally, Alex maintained a private consultancy called Additive Economics to provide expert strategic advice to investment firms, company boards, and government agencies on the commercialization of and investment in additive manufacturing technologies. More recently, Alex has been co-creator and occasional guest of Printing Money, a podcast on finance and investment in the additive manufacturing industry. Alex is a graduate of the Australian Institute of Company Directors and holds a Bachelor of Engineering from RMIT University. So in this episode, we talk about the tech behind nLIGHT lasers, as I already mentioned, what they mean for the additive manufacturing industry. We talk about how Alex got into 3D printing, which eventually brought her to the US from Australia, which is a move she just made recently as of this recording. She shares insights on the psychology and finances behind marketing and adoption of new technology. Specifically, she shares about the diffusion of innovations theory, which I had never heard of and found that very helpful and insightful for the kind of people and the customers and things that we work with at Raconteur. And then towards the end, Alex offers perspective and advice for women wanting to get into 3D printing and the STEM fields in general. I really enjoyed recording this podcast and getting to meet Alex and learning more about additive manufacturing, 3D printing, and specifically around her perspective from helping different technologies kind of find their place in the world and the things required to make that happen. So pop in your earbuds, maybe grab a snack, go for a walk, and enjoy this conversation with Alex Kingsbury. Hey, Alex, thanks for coming on the show.
Thanks for having me, Joe.
I'm excited to chat and learn more about what you do and who you are and whatnot. So to start off, I thought we could start with something a little lighter, maybe easy and fun. I was looking at your LinkedIn profile, and it has a really kind of unusual banner on the top of it with some colored, like fancy rainbow colored images. I wondered if you could talk about what that is and kind of just explain to people what that is and maybe the technology or the company behind it.
Yeah, oh wow, that's a great opening question. I mean, for starters, by the way, I'm pleased that you didn't say. I was looking at your LinkedIn profile picture, and it looks like it's maybe about 4 years old or 5 years old, and perhaps you should update it. I've been getting that feedback a lot, and I think like most people's LinkedIn profiles, they're usually well out of date, right? And
Mine included.
The banner, yeah, yours included. The banner is actually pretty much the only thing that's received an update of late. But yeah, so what that shows is laser beams, right? The intensity profile of some laser beams, and it was I thought it was. I mean, like you said, they're very pretty and rainbow. They're fun to look at, and I thought it was a great thing to. And really, I mean, I just hacked that together. That image we could do with having a much more professional banner that we give to all of our employees on LinkedIn that work in additive. But I work for nLIGHT as the market development manager for additive manufacturing. We make lasers, so we design, we make, and we sell lasers in the US, and we sell them worldwide, but we make them in the US, and our lasers go into really two different major major verticals. One is aerospace and defense, for anything from sort of, sensing to, counter drone activity. And then the other market is industrial, and those lasers go into cutting, welding, microfabrication, and in my zone, additive manufacturing. And the lasers have the lasers that we make have particular value propositions, and we're pretty clear about where we play really, really well. And so when it comes to additive, the lasers that we make standard lasers that you can, we believe are still differentiated, but basically pretty similar to a lot of the other lasers that you can buy from anyone else. But we also make a laser we call it AFX, and so it's a beam shaping laser. So if I could describe really simply the difference there, in a standard laser, we have what's called a Gaussian beam, right? So your typical bell shape, that's the intensity profile that's going to hit a substrate. And in the case of additive manufacturing, that's the intensity profile that hits a powder bed system, so a bed of powder. And the thing about that Gaussian distribution, intensity distribution, is that in order to get the intensity that you need at the sides to do complete melting of material, you need to really increase the intensity at the center. And that means that you're going to be over boiling your materials, and you're also going to be hitting that powder bed with an intensity and force that is much beyond what that material actually wants to accept. And it has a whole lot of impacts and ramifications for not only the melt pool, but the part that you're making, but also in what happens to the elements in the material that you're building, and also the quality of the melt pool that you're generating, or the stability of that melt pool. Okay, so what beam shaping does is it delivers the beam in a non-Gaussian mode, which is we use rings. So what we've found is if you can deliver the laser in a ring shaped, what that means is that your intensity is much flatter, and then as that translates, the intensity translates to the heat input, it's completely flat. And so that makes for a much more stable melting process. It means you can get a lot more power and heat into the melt pool without disturbing it. It leads to a lot less soot and spatter popping up out of that melt pool that you tend to get with the Gaussian beam, which means that soot and spatter is like the leading cause of defects in additive manufacturing. And it also means that you can greatly increase your processing window. So because you can get more heat in a much more stable fashion, you can go a lot higher in power. And that means with high power becomes higher speeds. Higher speeds means higher build rates. Higher build rates means a lower cost part at the end of the day. That's really how that translates. So basically, if you're switching from a Gaussian, which is what all of additive manufacturing has used ever since additive manufacturing started, ever since we started putting lasers and metal powders together to try and create parts, switching over to a ring beam, it is quite a shift in processing, and as much as it's still a laser, it's a shift. But using that Gaussian beam, we've only ever been able to get to about 1 kilowatt of power into a powder bed. When you switch to a ring beam, you can now start to push beyond that 1 kilowatt zone. And like I said, that's what really translates into higher build speeds, cheaper parts. You build cheaper parts, and then you open up your application space. So suddenly something that was not going to be viable, economically viable, there was no business case to 3D print it, becomes viable.
Oh, that's fascinating.
I know that was a really long answer and not especially a straightforward one to your question, but that's basically what it is. You see on my LinkedIn profile on the banner is intensity maps of the rings, the different index settings that we have, because there's more than one index setting, more than one ring shape that you can use.
Okay. I might show off my ignorance here, but what's the like in real life, what's the projected area of that laser beam when it hits the powder bed? And that those rings, like what's the actual area that those rings are happening across?
Yeah. So you can have, I mean, it's called a spot size that we aim to put down into a powder bed. The spot size is, so you want to be careful about what spot size you use, just because it depends on what you're building, right? So if you're building a part, you want to have a really good surface finish. And so you tend to use a really small spot size, really fine spot size for the contours. And you
Okay.
use a much larger spot size for what's known in the polymer material extrusion world as the infill, right? It's the bulk bit in the middle of the part. If you're building that bulk bit in the middle of the part, you want to have a wider spot size. You can do that with a Gaussian beam. So you can have a small spot size and a big spot size using a Gaussian beam. But the way that you do that is by defocusing the laser. So you defocus it and sort of stretch it out, basically. Whereas we don't do that. We don't do defocusing with ring beams. So what we do instead is switch from a really fine spot size. So we have in our AFX lasers, they're called programmable lasers. And you've got 7 different settings that you can use, everything from index 0, which is a really fine spot size, and it does have a Gaussian distribution, to up to index 6, which is our largest beam diameter. And so you can get something that's looking at sort of anywhere from the tens of microns spot size up to the hundreds of microns spot size. It's generally
Gotcha.
the length that you're looking to go over. Additive manufacturing will use powders that are in the range of sort of, anything from 15 microns up to 75 microns, larger sometimes. Sometimes smaller. It actually depends on what 3D printer you're using. It can also depend on what you're wanting to achieve with your build. It depends on the parameter set you're using. I know I'm using a lot of "it depends" statements, but that's the
Yeah.
kind of classic engineer's response, right? But yeah, so you want to try and use the spot size that is right for the part, not only the part geometry, but also the powder that you're working with. As well.
Okay.
That's really important. If you've got a powder particle that's larger than your spot size, which is, it's not ever the case, but if you think about that as a situation, that's not going to enable full melting.
Right. That makes
Yeah, so
sense.
you want to have those spot sizes much larger than your powder particles, and likewise, your layer heights as well. What's the layer height that you're looking at using in it? I mean, I should mention, in addition to higher scan speeds, with higher power, you can actually increase your layer height as well. And that's one of the things that has been, it's one of the areas that the 3D printing community has been trying to tackle for a long time, because layer height increases will, directly translate to time savings and cost savings.
Gotcha. That kind of makes a nice transition into the next thing I wanted to ask you about. Before the call, we were talking about a little bit about this kind of winding path that you've had, that you worked in media, kind of within the 3D printing stuff, and I know you worked in some other areas as well early on. So I wondered if you could give people kind of the 5-minute story of how you've came to where you are right now at nLIGHT as the market development manager, and kind of the path that you took to get there.
Yeah, sure. So 5 minutes, put me on the clock. I did chemical engineering as my undergrad. From there, I moved into oil and gas and mining consulting as a process engineer. From there, I was doing that as a consultant. I actually was really quite keen to work in a more sort of applied laboratory site-based role, and so I applied for a job at what's called CSIRO. It's the Commonwealth Scientific an industrial research organisation. So it's Australia's answer to what would be like kind of your national labs in the US or the Fraunhofers in Germany, for example. Everyone always says the I in CSIRO is really important. So it stands for industrial, and that's kind of key. It's industrial research. I started working in the light metals team, doing process evaluation. Really what that was commercialization feasibility studies, looking at everything from taking a lab-based technology into a commercial-based scale, so doing the scale-up design, and then also doing the financial analysis and the market analysis that complemented that. And so really all that was doing is saying, how can we make this lab-based technology commercial and attractive to industry? And a big part of the work was pulling in industry funding for those projects. And I was in light metals. We were working a lot in metal powders and metal powder consolidation. I joined in 2011, and that happened to be a really great time when 3D printing was, metal 3D printing was really taking off, and there was some really good, I wouldn't say really good, but there was some robust enough commercial systems that were available. And so as an organisation, we decided to invest in 3D printing. We had a lot of capability from casting and welding that we felt would be very well transferred into 3D printing, and we were correct in that thesis. It very much was, and it was a great time to be an engineer at a research organisation. So that capability just grew and grew, and we had a lot of organisational support. We also had a lot of industry support. We had great research projects. Personally, for me, it was a huge opportunity to grow my capability and skill set. And I ended up my time at CSIRO being the director of our lab there. We grew that lab, by a number of different machines, huge number of industrial partners. We developed a new model for engaging with industry, and was also the research group leader. So I got to do a lot of things like research project management, oversight, but also IP, intellectual property, portfolio management, and also heavy engagement with industry. At the time, this was sort of 2014, 15, 3D printing was experiencing this huge hype translated into, for us, and particularly in the Australian media landscape, as let's go and interview our national research organisation, because we offered an unbiased voice on what 3D printing was and how it could be used. And so through that, I had a number of different experiences with the media. I ended up leaving that role. I had a lot of, it was a fantastic time, like I said, to be at an organisation like that. I just had my last baby. I have 4 children. So I just had the 4th. And I'd had a lot of opportunities, or a lot of invitations to do consulting work at that point. And so I decided, I was on my maternity leave, and I thought, well, I'll go and do some work in this as a private consultant. But I'd also had, like I said, coupled with a lot of this media work. And so I think I'm almost on 5 minutes, Joe. But to cut the longer story short, what that meant is that I picked up a number of different consulting roles that were really enjoyable. If I could describe what it was that I did, it was really ended up being technical due diligence around financial decisions, right? So if there was an investment internally, or if there was an acquisition, if there was an investor looking to get a little bit smarter, those were the kinds of things that I did, the kinds of projects that I worked on. But having had that media experience as well, I just sort of naturally fell into a lot more of the public speaking type engagements, and that sort of flowed on to getting much more familiar with the media landscape. And then in the end, first I hosted a news show in Additive Manufacturing, which was hosted by a media company, and then after that, created the news show and co-hosted it, and then in addition to that, created and co-hosted a podcast. So that's and the media stuff has always just been lots of fun for me. I've just enjoyed it. I've never seen it as being necessarily core to what I do, but it also has given me a huge amount of opportunities and allowed me and enabled me to meet so many people that it's always just been something that's a great thing to have. And I guess that brings me to now, which is actually the CEO at nLIGHT actually got to know me through one of the podcasts that I was co-hosting, and reached out and said, I think the podcast is great. I'm a huge fan. can we meet up? And so we met up at one of the shows. And, that was, quite the significant meeting, as it turns out, in hindsight.
And that led to you kind of moving literally around the globe, right?
That is correct. Yeah. Yeah. Not an insignificant move, that's for sure. Anyone who's ever done, moving sucks, right? But anyone who's ever done an international move, it really sucks. Yeah, it was a big move. But having said that, I did sort of find, I don't mean to be down on my own country, but the industry in Australia is not sort of especially advanced. And look, it's not, maybe it's more about what my benchmark was, because I was doing so much work overseas. The consulting work I did was, I remember once I worked it out in terms of revenue, it was 96%. So it was countries other than Australia. And in addition to that, I was doing a lot of traveling and attending conferences and shows overseas, meeting with customers overseas. So I think I was just starting to feel a little bit like I could see the advancements that were happening elsewhere. And my baseline was pretty high. In terms of the kinds of companies I wanted to work with, the things I wanted to work on, and the kind of role I would be interested in. And so I didn't really see that there was a huge amount of opportunity that was left for me in Australia. I felt like I kind of took it as far as I possibly could. And and look, the role that I'm in now is, again, in hindsight, you kind of think, you work these things out, but it's exactly what I was after without even knowing it, because I wanted to work in additive manufacturing. It's been the thing I've worked in for over 10 years, and I felt like there was a lot of opportunity to really harness my knowledge and capability to date for a role in additive. But I wasn't especially keen to work in kind of like a services type industry. Like a big sort of showstopper is actually my citizenship. If you're not a US citizen, it's actually really difficult to work in 3D printing, because there's defense is a really big market vertical for additive, right? So no US citizen, all of a sudden it's like, you're out of the conversation, sorry. So if I was working on anything on the services side, it'd be difficult without US citizenship. So that's always something to consider. So it was always going to be something kind of like auxiliary to 3D printing. And, let's say if I ended up working with an OEM, so original equipment manufacturer, someone that supplied 3D printing machines, that would be just fine. But my challenge is that because of the roles I've had in the past in research, working as a consultant, working in the media, I've always had that position of being like a relatively independent operator in the space. And what I mean by that is, like, there's no favorites. There's no, not one 3D printing company is my favorite. And I'm so used to working across, lots of different customers, and having that full flexibility. And if you're working within an OEM, you definitely have like a lot of access and flexibility with your customer base, but you're not allowed to go and talk to the other OEM. They're your competitors. And so it's really nice working at nLIGHT, because we're a supplier to the OEM. And I feel like I get to participate so fully in the additive industry because of that. Or I get to continue to participate fully.
Honestly, that's a big reason. It's one of the favorite things about the position that I'm in, as well, is that being outside of any specific industry, we can serve lots of different customers doing interesting things without kind of being siloed into this specific thing. And I think it's just a lot of fun to be constantly
Absolutely.
learning and exploring new things.
And I have to say, it's been great in terms of when you have the partners that you work with. And I have to say, at nLIGHT, yes, we have customers, but the customers, and particularly in the space, that I'm in, working in additive, our customers are partners. You are co-partnered on an outcome. Their success is our success. They sell more printers, we're going to sell more lasers. And also, probably more to the point, we're constantly innovating. And so, wanting to know how to stay one step ahead. The AFX is a really classic example. You can get beam shaping solutions from other providers, but they are just, and maybe I'm sounding biased, but I don't really care. I mean, I knew about nLIGHT because I bought one of the machines with one of their lasers in it, and I bought it because it had an nLIGHT laser in it. So, I was a believer in nLIGHT before I joined, but I feel like we have an innovation roadmap that is really aggressive and really like 2-3 steps ahead of the other competitors. And so the reason I say that is because with our partners, and like I said, it's not customers, it's partners, we get to participate in that roadmap together. So they'll tell us what they need, and then we'll take that back, and work on what we think that translates into. And likewise, we're right there in the guts of the laser. That is the thing that drives these 3D printers. So we're always thinking about what we need to do next to stay ahead, and then we give our partners, the access to that technology because they're already in our ecosystem. So it's nice to have that relationship across like so many different OEMs. And quite frankly,
For sure.
if there's an OEM out there that's not our customer at the moment, then they should be. So
yeah, give them a call. Fast forward to the end of this podcast and find Alex's contact.
I didn't think to turn this into a sales pitch.
Background and stuff. One of the things that stuck out to me was this pairing of the media experience and the research and your consulting that you've done, which I think gives you a really kind of unique lens to look at companies and technologies. So I'm curious if you, in like this hypothetical scenario, or we can even relate it back to what nLIGHT is doing right now, what are the biggest obstacles that you see in a really exciting, disruptive, potentially, market-changing technology? What are the biggest obstacles, and how do you navigate that thing, finding it's a good fit in making a difference for your customers? And specifically, I'm curious if there are communication issues that you run into with, because the technology is so cutting edge and people oftentimes have a difficult time understanding how this stuff fits into their worldview. I'm curious if you have any just expertise to share on that front.
Yeah, so I think that as far as like sort of barriers to adoption, you've got a couple of like pretty classic ones. And what is this technology and what can I do with it is the standard. That's when you're working with a user base that potentially is coming off a low level of knowledge. One of the things that I really like to think about when I think about adoption of anything new is that diffusion of innovations theory. And when I was working at CSIRO, it was funny, we had this like dichotomy happening, because on the one hand we had research projects with global partners, right? And then on the other hand, we were trying to work with the Australian industry, and this is going back more than 10 years, right? So the education level was not high, where they were saying, what is 3D printing? And, I didn't know I can print with metal, and how do you do that? And, and so the level of knowledge was really low. And I think we went into it thinking that the traditional manufacturing base would be the ones to adopt 3D printing, which, of course, in hindsight, I think is a pretty naive take on things. But this is where learnings come into play. So had that kind of basically pretty painful experience, which is the traditional industry is not interested in adopting a new technology. And actually, it was a lot of the startups that were really open and keen. And so, I mean, look, we realized this, and we were able to, somewhat like craft and pivot our message and work out who we're trying to reach. Look, reasonably quickly. It's not like it was a really painful and expensive learning, but it was definitely a learning, and one that took me by surprise. And it was not until a few years later that I actually saw the diffusion of innovations theory, and about basically what it's saying is there are just certain types of people with certain types of psychology that will be open to adopting something new. And so you have on the very end start of this tale the innovators, and then and they're going to be the ones that are going to try everything. They don't care if it doesn't work. They just want to be the first. They're just super excited for something new, and they're always wanting to be on the cutting edge. Moving into sort of the early adopters, and they're the group that kind of like they don't care if there's no manuals. They're just interested and they want to see how it works, and they want to try and make it work. And then the early majority, who are the ones who are like, I need to have a certain level of reliability, and I need to have a community of practice around this, and I need to have this be more widespread, and I need to see that there's proof of something working. And then you get into the late majority, and then the laggards that kind of, that sort of speaks for itself. But anyway, the point being is that you actually just have to be patient with the process, and also work out how to communicate to those different groups. So you've got different messages that go to different groups. That the innovators are going to have a very different message, or need not a whole lot of convincing. But the early majority, that's a different set of messages, and they're the ones where you need to really craft communications accordingly. So that's the first thing I would say in terms of like how we communicate. There's been some debate as to where 3D printing sits, and I mean, I come at this from a very metal 3D printing perspective, probably important to remember. And I think, polymer printing is definitely about sort of 10 years ahead of metal 3D printing. In the metal space, where are we? We're kind of somewhere between, we're somewhere in the chasm between the early adopters and the early majority,
Okay.
and working our way across that. But anyway, I think that's, as far as communications, that's the one takeaway. There is work that the 3D printing industry needs to do, and in terms of, quite specifically machine reliability and capability as well. Sometimes the ask to get people to design for AM, which is a pretty common expression in the 3D printing industry. And by the way, AM, additive manufacturing, 3D printing, it's all the same thing. But yeah, you've got to learn to design for AM, and that's sometimes a little bit too much of an ask. So sometimes it's more a matter of, you've got to try and find a business case for something that's just horrendously expensive to manufacture. It's too much of an ask sometimes, and so that's the kind of thing that will work with the innovators, that very initial tail. But it's definitely not something that works for the early majority. The early adopters will do things like the DFAM courses. They'll get on board with that. Learn how to design for EM. But yeah,
Gotcha.
The early majority, they're not interested in how do I make some business case work necessarily. One of the biggest challenges facing 3D printing today, though, is the financial landscape. And I see that and it's not a bad thing, actually. We've had a really interesting time globally in the financial markets over the last 3 years, right? So we had, 2020, there's a pause, 2021, it was just this like, inflation goes through the roof. The public markets went crazy in 3D printing in particular. A lot of those 3D printing companies did SPACs. It's a special purpose acquisition company where you do like a backdoor listing on the public market. You had loads of money just being thrown at 3D printing and tech and other industries as well. And then 2022 was, a real cool down, and there was a whole lot of disappointment in the financial world. I'm talking specifically around 3D printing, but in general. And this year, 2024, is the year of reckoning, really. You've got companies who are in very, very, very tight places, unable to raise more capital. The ways that we value companies have completely changed. We used to value them based on growth projections. We're not doing that anymore. We have reverted to a much more sensible, in my opinion, and realistic way of valuing companies, which is what's your revenue, what's your gross margin, and what does profitability look like, or even just your path to profitability. And that's kind of really started a big reality check process that's happened now. And we're seeing companies get a lot more customer focused, which is good. This is what was needed. I mean, wow, what an original idea. Please be more customer focused. But probably to the point of the 3D printing industry status, it does mean a lot of these companies were sort of very growth oriented, but also very innovation oriented. And I do think we're going to start to see a bit of a pullback in innovation as these companies, number one, cut costs, which they need to, but also, really apply themselves to very customer specific inquiries and customer specific needs.
I agree. I think especially the VC environment for the last while, it seems like it's been operating more like a casino than like building really reliable businesses.
Put it all on black, Joe.
Yeah. Maybe that's I don't know. Maybe that's something I shouldn't put out publicly, but opinions are my own, not my customers.
It's your podcast. You can say what you want. It does seem like there was a lot of and actually a good friend of mine, Arno Held from AM Ventures, was just at a conference last week, and he gave a talk where he said, and I agree completely, there was a lot of dumb money, right, that came into 3D printing. Excess money, it does fuel innovation, and it fuels innovation, not necessarily competition, but definitely helps prepare companies for really reaching some of their big bold plans and achieving these big ideas. But there's not a lot of accountability with dumb money. I mean, it sort of astounds me that sometimes, and particularly in the Silicon Valley little ecosystem, they don't even demand a board seat. I just can't imagine, putting money into a company, not even asking for a board seat. Not to mention some of the, I mentioned I worked in, consulting, and specifically around due diligence. The diligence that's done on a lot of these deals is very poor, or at least it was then, because it was just a matter of just like, need to push money out the door. Sounds like a good idea. Let's just do it. We'll put in this much, and not a lot of thinking really about how to spend that money wisely. One of the things I think is funny though is like everyone's like, oh, there needs to be a look back and some lessons learned, and I'm like, it's never going to happen. It's never going to happen. It's just a financial cycle. Guess what? We've plowed a whole heap of money into this industry, and now we need to make it work for us. And so, if you've been spending too much, then the day of reckoning, I think, is nigh.
Yeah, for better or worse, I think you're right. The day is here.
Yeah. On the flip side, though, companies that have managed themselves really well, and maybe are actually kind of like maybe profitable, or at least have a really like focused go-to-market plan, very applications focused, very solutions oriented. I mean, they are standing themselves in really good stead for the future. So I think that's a lesson. If there's a broader lesson to get out of this, it's like the hype and the craziness isn't good. Remember what that business plan is, and who you are and what you're trying to do.
Yeah.
Good advice for life, really.
It is. It's true. So I do have two more questions. So I'm curious what technologies if you can talk about them, what technologies in 3D printing are you really excited about for the next 10 or 20 years?
Yeah, so I mean, I will save you the second sales pitch, obviously. Um, and I'll do the courtesy of moving outside of laser powder bed fusion, which has been the space that I'm majority preoccupied with at the moment. Another space that I've been working in and have worked in the past is directed energy deposition. So this is where you're taking a heat source, be it a laser or an electron beam or even an arc, and a material input, be that metal powder or a metal wire, and you're fusing them together, basically in a tool path. And I think DED, so it definitely differs from laser powder bed fusion. It's got a different value prop. It's generally better with larger scale parts and with parts that are more kind of near net shape, called near net shape. So, not a completely finished product at the end. It might need a bit of like post machining. But DED is a technology that's been a little neglected, in my opinion, and I think it is already growing at a higher rate than the other technologies. It's growing at a higher rate than laser powder bed fusion, for example.
Okay.
I mean, it's debatable, to be honest, how you measure that growth. So it's usually measured in system sales, and that's maybe not entirely. I think we do have some issues with how we capture data and measure growth, but in general, even my anecdotal experience is that DED is growing, and it is kind of like the next thing on the horizon. But part of the reason I think DED is exciting is because it actually is much more similar to welding than it is laser powder bed fusion.
Okay.
And
I was going to
so,
ask.
we have capability in welding already that exists. We have knowledge bases that exist in welding. We have very experienced users in welding. And so, in one way, it kind of, you wonder why did we not explore this technology first, than laser powder bed fusion in the 3D printing realm. But yeah, nevertheless, that's experiencing some growth. Binder jetting, it would be completely remiss of me to not mention binder jetting. So that is a technology that it's basically where you're jetting a binder, i.e. like a glue, and gluing metal powder particles together. And you can make a green part and then go off and furnace it and produce a final part. It's actually been around for a really long time. It's never really taken off to the extent that it should have. I will say, I say this all the time, but binder jetting is hard. It's really hard. It's hard to make it work. It's very difficult to do binder jetting in a way that you require such a precise level of exactness. You've got a couple of different variables happening, the droplet of a binder material, you've got the metal powder sitting there, and then you've got this sinter operation that happens afterwards. You have shrinkage factors, you have geometry constraints, you have material constraints. So there are definitely challenges with binder jetting. However, this is definitely a technology that is going to be really useful for relatively small parts of not a huge amount of complexity, but will make manufacturing of them very accessible and easy. And so, the auto industry, I think, will be a big recipient of binder jetting technologies. And then the other thing I think, which is really interesting as a concept, is, and we're sort of seeing how this is all playing out, but at the moment this seems to be really evolving, which is this factory in a box type concept where you have, basically the whole industry is moving to a state of, it's not necessarily good enough to just sell a machine. You actually need to sell a solution. And this is maybe going more towards that, trying to be more customer focused. So, sell a customer a machine, and then they realize, I actually need maybe like a heat treatment furnace, and I might need a wire EDM to cut my build plates. and I might need a CNC machine to do some post machining, and there's any number of additional things you're going to need, or even just basic things like the build plate is very heavy when you have built a whole part on it. And you might need some assistance in terms of taking that build plate out. And maybe you might want to consider, like, if we're going to turn this into an operation, like a robot. And so what I'm saying here is that there are so many other things that have to support this one process, that what now is emerging is this concept of, like, for example, no, Joe, I'm not going to sell you a machine. I'll sell you a part. I've got my own 3D printer, but I've also got all the other things that you need. And I can just, I've got that sort of worked out sort of now in an ecosystem that works. And I know that I can sell you a part really successfully. I can't necessarily sell you the whole system that works to make that part, but nor would you probably want it. And if you get, if you get to a certain level of volume in your need of parts, then we can talk about taking that whole system, that whole ecosystem, and moving it somewhere else, replicating it somewhere else. So that's this, like I said, this factory in a box situation. But this is our OEMs or people that build printers. That's them realizing that selling someone a machine and expecting it to work and expecting them to have all of the infrastructure to support it, and then also when it goes wrong, which inevitably it does, because it's new technology, something's going to mess up, then you're going to have to support it with service, and that's a real killer as well. So I think that's a very exciting emerging concept.
It seems like that really goes hand in hand with what we were talking about earlier, with this kind of return to customer needs. That it's
Exactly.
everybody's is really focused on how can we solve the root problem in the best way possible, and let's build our businesses around that, as opposed to, like you said, just selling a product.
Yeah, and I also say, it's that move and that shift has gotten the OEMs, the people that will sell you a machine, to get a lot wiser around partnering in an ecosystem and being able to offer that to customers as well. So it's requiring them to sort of step up and have a solution, for customers as well.
So another fun one, I hope. You were involved in, I think it was women in 3D printing in Australia.
Yeah.
So I wondered if you had any advice for girls or young women who might be looking into getting into AM, or even just the STEM fields in general. What would you say to somebody who has that on their horizon?
I guess I would say, I'm not going to sugarcoat things and say that's like super easy, but I've experienced I've experienced plenty of challenges in my career to date. Were they because I am a woman or not? Sometimes you can tell, sometimes it's pretty clear, but most of the time you can't tell. And the reality is, everyone experiences challenges in some way, of course. But I have found, I've definitely found engaging with women in 3D printing has been a wonderful thing to do, because sometimes it's a matter of even just being able to talk with another woman who's working in your industry, and being able to throw something around. This happened to me the other day. I heard this, so and so, whatever the case may be, and discuss it in a safe environment, where other women have been through similar things, and can say things like, "That's not okay." If you're questioning whether or not it is, or sort of give another perspective on things. So the support of other women has been really crucial. And unfortunately, I think in the STEM fields, or in any field where you've got an imbalance, you're the minority, there can be a really unhelpful dynamic that's set up, which is you're the only one in the room of that category, right? So I'm the only woman sitting at the table, and I recognized pretty early on in my career that this dynamic would happen, so that if another woman would enter the room, the women saw themselves as competitors, which is kind of ridiculous because it's like almost this scarcity mentality of there's only one seat in the room for a woman here, and that, you know, being able to break that, recognizing that pretty early on, and being able to break away from it has been really very important in being able to develop healthy and beneficial relationships in this industry. And and I think that it's because it is really important to connect with, again, there's minorities of lots of different types and varieties and flavors, but in particular, talking about being a woman, it's been really important for me to connect with other women. It's been a huge source of support and inspiration. But likewise, I would not be where I am without the support of men in this industry as well. So, it's a male-dominated industry. If I relied only on women for support and help, I would never get anywhere because, quite frankly, there's just not that many in the industry. And so, men being sort of career coaches in a way. I've never had an official mentor or anything like that. But I also don't necessarily think that the best supporters come from that domain anyway. You have coaches and mentors that are unofficial in so many different walks, not only in your job, not only in your industry, but also in life. And I've always been very thankful for the support I've received from the men that I've worked for, because there are some absolutely top quality ones around that have just absolutely, helped me so much. I think your question though was advice. And one of the bits of advice I think is, always reach out. You would be amazed how much people are willing to help, particularly when you're in your earlier career. It shows that you're dedicated and you're keen, you're taking initiative. I wouldn't recommend ever reaching out to someone, if you see someone where you think they have the kind of job that I would love one day, and they have the kind of career that I would really like to have, or if there's just something about them that you just think, I feel like I could learn a lot from them, there is nothing to be lost from reaching out to them and asking for advice or asking for help or asking just to have coffee, right? And being transparent about, I would love to be in your job one day. Or it could be I don't have a lot of experience in sales and I would love to know more. Can we have coffee? I'd love to know about your techniques or how you developed your strategies or whatever it is. People actually really like to help. So, and the worst that can happen is that they say no, of course, and that's not the worst thing either. And honestly, if someone says no, that's on them. Like that, that's not a. I think if you're a more experienced or older person in an industry, and a younger person comes and reaches out for assistance or advice or help, and you say no, they don't really deserve to be around. I don't think there should be a lot of room for those kinds of people. People are busy for sure, and I think that it's also really important to be quite specific about your ask, and specific about what it is that you want. It's actually something I probably really struggled to articulate, like what I want specifically, but being able to articulate what you want, even if it's only very small, like even if it was in the example of sales, like even if it was like, I would love to get just a little bit better at sales and sales techniques, that is very helpful, very, very helpful. And again, maybe what did I say before about the, know who you are and what you want? It's really, really important.
I would definitely agree with that. And ironically, one of the coaches that I've had who is a woman, was one of the things that she worked with me a lot on is just ask. Like in general, people want to help.
Yeah.
Somehow I think often there's a paradigm that have certainly had, that the assumption is that you get rejected harshly, but in general, people are willing to help even if they can't because they're too busy.
No, definitely. And I think people in sort of more mid and senior careers, do see that as being kind of almost their duty to pass on to the next generation. The more you do that, the more you also just expand your network. And here's the other thing that's great to remember: everything is a job interview, right? It does it even if you think that something might not come out of a connection with someone, and you see no possibility for that ever happening. It's incredible the amount of times that these things will come back to you in one way, shape, or form. People know each other. People talk. People move jobs. So never, always bring your best self to everything.
Well said. So to wrap up here, two things. First off, where can people find you online if they want to connect, want to chat? And do you have any asks for anybody who might be listening right now? What do you need?
Okay. Best place to find me would probably be LinkedIn, I would say. Alex Kingsbury is my name. And if you can't find me there, just Google me. There's some New York Times journalist also called Alex Kingsbury that tends to get a little higher in the SEO ratings. But if you maybe type in Alex Kingsbury Additive Manufacturing, you'll definitely find me. Probably a good way to get in touch. And final words would just be, well, first of all, thanks for your time, Joe. Thanks for doing this. I know the podcasting and doing all the post-production and the publishing of podcasts and all of that, it's actually, there's a lot of work involved in it. So I appreciate your time. I appreciate you reaching out to me. And to everyone else, thank you for listening, and stay happy and get printing.